Good morning, Year 8. I hope you've had an enjoyable bank holiday weekend and we're involved in some VE Day celebrations. So today's lesson is based on the area and circumference of circles. You should recall that the end of last week, our second lesson of the week was based on the areas and perimeters of some of the more basic shapes. So today we're focusing on circles and next lesson we'll be looking at some arcs and sectors of circles, though some people in our extension day might be looking at those as well. So lesson objectives today are going to be calculate area and circumference of circles. Secure students will be looking at area and perimeter of semicircles and quarter circles, and then excelling students will be looking at compound shapes involving circles. Remember, compound shapes from last lesson, shapes which are made up of several more basic ones. So as normal, please, if you could send me a little message on showing my homework so that you're accessing the lesson, I can put you on my register. Well done, I was giving loads of reward points out on Friday, so well done to those who've achieved those points for accessing our previous lessons. And then today's activities are going to be self-assessed with answers on the video. Our second lesson this week will have quite a few My Maths activities attached, so there's no need to send me any work this week. Just please get in touch, so if you have any problems I should be able to assess everything online via the My Maths activities on Wednesday's lesson. So without further ado, we'll move on to our starter activity. So starter, which of these shapes has the greatest perimeter? And then which has the smallest? And what are those perimeters in algebraic terms, in terms of d, the length that is given on the shape itself? So if you'd like to pause the video until you're ready to go through this, and then we'll go through what you should have got. Okay, time for the answers on this. So our first shape, the square, you should have had a 4 sides all of length d, so we had our 4d as our perimeter. The hexagon there might be a little bit more complicated to get, but if you split up that horizontal line throughout the middle, then you actually get half of whatever the letter D stands for. And then you should recognise that a regular hexagon is made up of equilateral triangles. So actually each of our lengths on the shape is going to be half D as well. So we've got 6 of those being a hexagon. So our total perimeter for this is going to be 3D, 6 lots of half D. And then for our circle, then you should know already that the circumference of a circle is pi times the diameter. So it's going to be somewhere between 3 and 4. Now you might know that pi exactly is about 3.14, but for our purposes of putting them in order, you're going to be exact there and put the symbol pi. So you can see the shapes overlaid there, the area, you can see there as well. So the square would have the biggest area, circle would have the middle area, and then the hexagon would have the smallest area if you're being asked to work those out. So if you've checked your answers, then we should be ready to move on. So we're going to have a look at how the circle formulas are derived for area. And we should know circumference already, we just mentioned that was pi times diameter. So if you imagine a circle which has a radius of r standing for radius obviously, then this circle could be split up into sectors. And you can see the little pieces there, the little slices we've got. Now this is where our mathematical terms diverge a little bit from our regular speaking. If you were looking down at the top of an orange as it was cut up, you might have thought that those pieces were called segments. Segment is something slightly different in maths that we'll have a look at on Wednesday. So these pieces are definitely sectors of circles. And what we could do is we could rearrange these sectors, one pointing upwards, one pointing downwards in a line, as we can see, and make a new shape. And we can say, well, what shape is this? It's very rough, but actually it's starting to look a little bit like a parallelogram. And if you were to cut those pieces even smaller, if we had our segments half the size, or even a quarter of the size, or an eighth of the size, it starts to look more and more like a parallelogram. But what would the measurements of this parallelogram be? Well, the edge of this parallelogram, so the top and bottom, is made up from the edge of the circle. And we know that the circumference of a circle is pi times the diameter, or in this case 2 pi r, because doubling the radius gives us the diameter, and therefore half of the circumference is just pi r. And that's what we've actually got at the top and bottom of our parallelogram-esque shape here. So this line at the top here is using half of the circumference of the circle, and the line at the bottom here is using the other half of the circumference of the circle. So actually our base of our parallelogram is pi r. What about the height of the parallelogram? So the radius of the circle is a line pointing from the centre to the edge. Well, actually that's what our pieces are looking at as well. So the height of these pieces is also r. So if you can imagine, because it's a little bit off on this diagram, so we've got big sectors. So the radii that we've got here on our sectors of the circle, if our sectors were getting smaller and smaller and smaller, and there were more and more of them, you imagine this radius actually starts to become a vertical line, and therefore we can get our area of our parallelogram shape. So base is pi r, height is r. We should know from last lesson that the area of a parallelogram even is a base times height. So pi times r gets us our pi r squared, that again you should have been aware of for the area of a circle. That's just a little talk through on how you should get there. You can try that out yourself if you wanted. You could draw a circle, cut it out, fold it into as many pieces or as many halves as you can, try and get more than 8 pieces, and you could imagine those pieces getting smaller and smaller and smaller, and this shape that we make gets closer and closer and closer to a perfect parallelogram as we get smaller sectors. So how do we actually use these formulas then? So we should know our 2 different measurements of the circle. We've mentioned already, we've got r for the radius, a line from the centre to the circumference, and then we've got our circumference of a circle, which is the perimeter of a circle, the distance around the outside, is pi times diameter. D for diameter being a line through the centre, but from one edge to the other, from one point on the circumference to another through the centre. So circumference of a circle is pi times diameter, and then area of a circle is pi times radius squared. So really important formulas you need to know. If you aren't aware of them already, then I would definitely get a record of those in your notes for today. They're going to be really, really important to use going forward. So some examples of how we can do these with numbers then. So we've been asked to calculate the area and circumference of each of these circles. Now these circles both have a difference in them. So what's the difference between these 2 questions? Hopefully you should spot that the first circle has a measurement of 6 centimeters, but this 6 centimeters is all the way across, so this is a diameter. And then in the second circle, our measurement is given as 4 centimeters, but this is only from the center to the edge, so this is a radius. So you need to bear that in mind when we're using our formulas, because remember our 2 formulas each use different measurements. One uses the radius and one uses the diameter. So first circle, if we were to work out the area of this circle, it's pi times the radius squared. Now be careful here, the measurement we were given of 6 centimeters was all the way across here for the long line. So if the diameter here is 6 centimeters, our radius is actually half of that, so our radius is 3. So for the area of this circle, we need pi times 3 squared. And then to 2 decimal places rounding, then that's going to be 28.27 centimeters squared. Remembering the area has to have our squared units here. Nothing to do with the fact that the 3 was squared, that was separate use of our formula, centimeters squared from our area. If you wanted then the circumference of this circle, circumference is pi times diameter. Handily in this circle we were given the diameter immediately, it was our 6 centimeters, so we just need pi times 6. Now, if you're unsure where your pi button is, if you're on one of the newer Casio ClassWiz calculators, then you should be able to press Shift, and somewhere down the bottom of your calculator should be a button that has 10 to the power of X, but above it is the pi symbol. So you need to press Shift and then that button to use pi, and it should come up with the same symbol there. And try and get involved with the use of the symbol itself to get really accurate answers. And that's going to give us 18.85 and just centimeters, because circumference is like a perimeter, it's just a length around the outside, so just centimeters. The second circle then, really similar process. If you want to work out the area, we need pi r squared again. In this case though, we were given our radius. The radius was 4, so this is going to be pi times 4 squared for our area. And then if you pop that in the calculator, you're going to get yourself 50.27 centimetres squared when it's rounded to 2 decimal places. And then for our circumference, same formula as before, circumference is pi times diameter. But remember, we were only given the radius of this circle as 4, so we need to calculate the diameter first. If the radius is 4 halfway across, then the diameter is going to be 8 all of the way across. So we're looking at pi times 8 for this sum to get our circumference of the circle. And then your calculator do the heavy lifting with this, and you should have 25.13 centimetres. There's quick use there of those formulas. So we're going to move on to a very, very quick activity, hopefully, where you can have a look at the use of these formulas. So have a think about how confident you feel with this topic, and then choose whether you want red, amber or green for your activities. I've had a few people submitting work where they've done all 3 activities. Bear in mind, all 3 activities are the same, it's just varying degrees of support. So the green activity is the first one that's on the Word file, and that is going to have 0 support. So there's some questions for you to try straight away about the use of this formula. The amber activity is the middle one. So the amber activity has a little bit of support for those questions. So there's a bit of a matching activity for you to do. And then the red activity is if you're not so confident with using your formulas for circles. So the red activity, it's the same questions as everyone else is doing again, but you've just got a little bit more support. There's a bit of frameworking with the circles drawn for you so that you can work out how to use those areas and circumferences. And you might want to rewind the video just a little bit to see how I went through them in order to do those questions. So you should be doing just one of the red, amber or green activities. And this should be for your circumference and area of circles. And once you've had a go at that, unpause the video so we can run through some answers. So answers available here, whether you did the red or the green or the amber activity. And then when you have self-marked, unpause the video so we can move on to our next step. So this is going to have quite a bit of writing on this slide. So again, you may want to copy some of these down as far as your notes go. I have colour coded them though as far as the colours of the letters go on this, so we can see which one we're going for. So we've got 3 different style of activities here. All of these now involve parts of circles. So we've got an easier activity here, which is going to be the red one later on, which is about half circles or semicircles. And then we've got an amber activity where we're going to be looking at quite straightforward fractions of circles. So these are going to involve quarter circles or half circles, or maybe even 3/4 of circles, but all 90-degree pieces. And then for our green activity on this, actually this melds a little bit into Wednesday's lesson as well. We've got a 45-degree sector of a circle here. So not half, not a quarter, but actually we're going to have a little think about that one later on. You might already have the fraction of it, but we're going to have a look at those in just a second. So for each of these, we're going to work out the areas first, and then I'm going to move on to working out the circumferences of them. So how do we get the area of our first semicircle? Well, if we think the area of a circle normally is pi times the radius squared, well, how much of a circle do we have here? We've only got half of it. So the area of a semicircle is the same formula, pi r squared, but we're just going to divide it by 2 at the end to get our half a circle. So here we've got our diameter given to us as 5 centimetres. Always watch out, don't rush in with your numbers. Here we've got the diameter as 5, so our radius you should be able to work out as 2.5. So our area of the circle here, let's pop the numbers in. Radius is 2.5 and it should give you 9.82 centimetres squared. Similar idea for our orange activity. How do we work out the area of a circle? Always put the original formula, pi r squared. But this time we've got 1/4 of a circle. So for our total area here, we have the same formula, but we're going to divide it by 4. Again, have a look at what numbers we're given here. We are given the radius in this question. The radius is 5, so we can run through and put r as 5 in our formula. So pi times 5 squared over 4 should give you 19.63 centimetres squared. Now the green question here, you've got to think about what part of a circle we've got here. So there's a couple of ways of doing it. I'm going to run through a way that will work always, but you might actually find a slightly quicker way if you think about simplifying some fractions. So again, start off with the area of a circle formula, and then we need to work out, well, how much of a circle have we got? Now, we should all know that circles are out of 360 degrees. So it's quite a long-winded fraction, but most of these questions will be calculator ones. So actually what we could say is we've got 45 360ths of a circle here, because we've got 45 degrees out of the total of 360. So we can apply that to our formula. Same formula as the area of a circle, but we're going to find 45 360ths of it. So we've times by 45 and we've divided by 360 to get our sector of a circle. Again, here we've been given our radius here, so the radius is 6, so we can plug r as 6 straight into the formula and get our answer then as 14.14 centimetres squared. So that's the run through of the red, amber and green, but just areas. Remember, we're also being asked for circumference of a circle. This is a similar process, but there is a little quirk on the circumference of circles and the perimeter of these areas, the perimeter of these objects, that we just need to be aware of. And this is due to the fact that if I had a whole circle, I'm going to shade it in there, imagine that's a circle, it's a little bit wobbly there, but if I was to find half of that area, that's fine, I've got this much, so halving an area to get half of a circle, brilliant, that just works absolutely straight on. But if we're talking about perimeters of circles, well, if I have a full circle's perimeter, so if I was to halve the length that I've made here, I only have the curved section. So actually when you're finding the circumference or the perimeter of an object made with parts of circles, if you do the circle bit of the formula and think, oh, we've only got half a circle, we'll half our formula, you'll be missing the straight line here. So we haven't actually got, and I'm going to highlight in red here, the straight line. So when you're doing your circumference or perimeter of these shapes, you need to add that straight line back on. So if we run through these then, circumference of our circle is pi times diameter. Here we've only got a semicircle, so we definitely need half of our original perimeter formula, but we also then would be missing the straight line, so we have to add the straight line in as well. So that gives us the formula of pi times diameter divided by 2 to give the semicircle part, but also we add on the diameter again to get this straight line added back in, otherwise we'd be missing it. In this question we were given the diameter straight away, so we can plug d as 5 straight back into this formula, and then you should have 12.85 centimetres in total. This idea then extends to our orange question here, this quarter of a circle. So we should know that the circumference of a circle is pi times diameter. Again, we've got a quarter of a circle, so we can divide that bit of a formula by 4, but remember this will only give us the curved line that I've highlighted here. So we're missing the two sides. So we're missing this line here, which is a radius, and this line here, which is also a radius. So we can see our formula here needs to be original perimeter pi times diameter, but in this case divided by 4. And then we need to add on the two straight lines that exist in our problem to get the full perimeter of this shape. So we've got d for diameter and r for radius here, so be really careful with the use of this in the formula. So here, if our radius of our question was 5, our diameter is going to be 10. So we want pi times 10 divided by 4 to get the curved part of the perimeter, and add on the 5 again to get your total perimeter of the shape, which would be 17.5 centimetres. Very, very similar with the green shape, we just had that little more thought about what fraction of a circle we had there. So we've got our circumference being pi times diameter as always. we said that we've got 45 360ths of a circle. Now, as I mentioned before, some of you might be thinking ahead here. 45 360ths is the same as 1/8, so you could get rid of the larger numbers here and just find an eighth of your original circumference if you wanted. But of course, we also have to add on our straight lines again, which, as we can see, there's 2 straight lines here. So add those back on to your shape at the end. So we want pi times diameter again, but 45 360ths of it, plus the radius and plus the radius again, and that's going to give you a total perimeter of 16.71 centimeters. So there's quite a lot going on with those. Now, I'm going to ask you guys to have a look at an activity based on this. There's only going to be a handful of questions on these, but I've got the 3 different variants of colours on this. So as we've mentioned before, the red activity is going to be based on semicircles. The orange activity is going to be based on parts involving quarters of circles, so there'll be some right angles involved. And then the green activity is going to be our sectors of circles, which could have any angle in them. So these questions are on the next slide. Here we go. So I'd like you to pick whether you're having a go at the red or the amber or the green. If you're feeling really brave and confident, you can have a go at more than one section on those and work your way upwards with it. Again, if you'd like to pause the video until you're ready to go through some answers to these, and then we can show those on the video. So your answers should be as follows. Just remember when you're writing your answers and make it really clear which is the area. Again, like you might want to put A equals for your area, and then make sure your areas have centimetres squared at the end, and then P equals for perimeters, and of course the perimeters just are going to be in centimetres or the regular units that you're measuring in. So again, please get in touch with me if you had any problems with those at red@theroyal.school. And finally then, we're going to move on to our compound shapes. So a compound shape here is going to be one that involves shapes made from the more basic ones that we should be aware of. So this shape here, we can see, hopefully we could spot that there's a rectangle in the middle, and there's a semicircle here, and then a semicircle here. So we've got 3 different shapes which we need to work out the area and the perimeter of. So let's run through our area part first. So first part of the shape, we have a straightforward rectangle. Area of a rectangle's length times width. So 8 times 12 is going to give us that 96 centimetres squared for the area of the rectangle. And just keep that to one side in your working, because we're going to need that as part of our total answer later. So we can then have a look at one of the semicircles. We're going to look at the one on the right here. Just be careful on your measurements here. We can see the vertical line in the rectangle at the left was 12, so we know that the vertical line across here is also 12, and then that is going to double up as the diameter of our circle here, or semicircle in this case. So the area of the semicircle, pi times the radius squared, but then divided by 2 because we only have half a circle. As we said, our diameter here was 12. So our radius of this circle, if you imagine it as a full circle, is going to be 6. So we want pi times 6 squared, but then divided by 2. And that should give you 56.55 centimetres squared. And again, put that to one side because we need to piece all of these together at the end for our total area. And then our final semicircle here, much in a similar way, we need our pi times radius squared and divide it by 2. You see that the top line of our rectangle was 8 centimetres, therefore this length here from end to end of the circle, so this diameter is also going to be 8, so the radius of this circle, or semicircle in this case, is going to be 4. So plug 4 as radius into the formula, and we should get the area of this semicircle as 25.13 centimetres squared. Now finally then, we had our 3 separate areas. So we can add to those together, get our final area for this shape in total. So we had our rectangle was 96, the semicircle on the right was 56.55, and the semicircle at the bottom was 25.13. So add those together, and then we get our total area of 177.68 centimetres squared. So that's working out the area of this shape in total. it is definitely worth showing each of your calculations separately and then showing that you're adding those together, so you would maximise marks in case of a single mistake in an exam. Now, if we were thinking then of the perimeter of this shape, then just be careful about which lines that we need. Perimeter is the distance around the outside of the shape. So we would need the vertical 12 line that I'm highlighting here. We need the horizontal 8 line that goes across here. You would need the half the circumference of the circle here with a diameter of 12. And you would need half the circumference of a circle here with a diameter of 8. And we wouldn't need, so I'm going to put them in red here, I'm going to put a line through them in a minute, we would not need this red line, and we would not need this red line. They are interior lines in the shape. I'm going to put a scribble through them. We do not need those included in our perimeter of this shape. Otherwise it would be virtually identical to the questions we were doing earlier. So if you're feeling confident, then we can treat this as the extension part of the lesson today for our compound shapes. So some of us might have spent enough time on today's lesson with the 2 previous activities, but if you've been working really well and are confident with your circles, you should have some time going ready to work on the extension here. So this is going to be our compound shapes. Again, it's split into 3 different sections here, so they're all going to be the same questions here for compound shapes. Again, green will have 0 support, amber will have a little bit of support, and red will have a bit more frameworking again to help you work in those if you're going to have a go at this extension activity. So once again, please get in touch with me at red@theroyal.school if you do need a hand. Please send me a message on pardon me, on Show My Homework to show that you've accessed the lesson if you haven't already. And then the answers to the extension activity here will be on the next slide. So please have a good go at that and watch the final couple of seconds of the video when you're ready to get your answers to this extension activity. Thank you very much. So answers to the extension activity here. If you did give this one a go, then please just send me a little copy of your work on Show My Homework, because I do like to give out extra extension reward points for those that have excelled with the work. So do send me a little message about that. Thank you very much.